Hello, Richard from Eagle6 Airsoft. We're going to be working on this Tokyo Marine Mark 46. So this one has come in, it's clearly got some previous work on it. It's got a rear wired thing going on at the back there, and it's got an extended barrel going all the way through. Not obviously what we would choose, but yeah, it's been done. Just seems a bit pointless to obviously drag a barrel all the way through there, only to have the FPS a smidge above obviously you know what it is standard out of the box. So we've obviously got to raise the FPS up, and yeah, and obviously, you know, the customer loses the ability to do the barrel. We've already taken this part off over here. It was all loose for the bipod, so there's a missing screw, so we're going to clean all that up and replace the screws and Loctite that, which arguably should have been previously by whoever worked on it, but it is what it is. So we're just going to strip it down and obviously, you know, check over the gearbox, install some gears, upgraded gears, probably increase the FPS with a spring if it's not already been done, and power spacers, and then go from there. So yeah, we'll just start going at it, I think. Honestly, people with extended barrels on these things need to be shot. Righty. So obviously this is the chassis, the main chassis here, so obviously everything needs to come out the front here, and we've got this stupid rear wiring going on. Right, so it's got a brushless motor, so that's already been done. It's one of the old warheads, so don't want to breathe on it funny or it will snap. Don't see the point in making this more complicated than it needed to be. You know, is the longer extended barrel in there and the rear wired simply a case of a customer demands it, and the shop felt obliged to do it, or is it some genius idea by a shop, you know, just to make it 10 times more work on an already hard gun? It just doesn't make sense, does it? Absolutely no issue installing batteries in the front wired. Easy peasy. Now I've got this sort of God knows what situation with the wiring going on in there and the MOSFET in there. You know, they've just been turned around and pulled backwards. Did they just chop wires? Did they resolder the board? Is it a different MOSFET? It's a huge unknown left now. Big old grey cloud over this. So this is the safety selector. So you want to be careful with these tiny screws, and if you do Loctite them, you know, don't put a lot back on. Don't want to make it difficult to remove. So that ain't going to come out until we pivot the gearbox. So we might as well just remove this magazine base mount while we're at it. You want to try and crack the screws because they'll often have either Loctite from previous gun techs or from the factory. So rock it backwards and forwards with your hands. You know, so like this, obviously just to sort of see if it is going to start moving. If it starts moving, then brilliant, carry on. So if not, stop and just get some heat onto it. It's just not worth rounding these bastards off. There we go, well, they're quite loose, which could suggest obviously not enough Loctite put on by previous tech. It's just something we advise on, almost like giving these things a bath. But it can obviously make then disassembly, you know, it's a trade-off. You know, do you make it difficult to obviously, you know, do servicing? You know, pain in the arse for the next gun tech, i.e. me doing it, or you know, do you risk obviously half the stuff falling out in the field? You know, we've already got a loose front bipod. You know, we've got these screws, you know, easy to undo. There's a backed out screw on this rear bracket assembly. It's something we had to factor in quite some time ago, because we've been working on these for quite a while now, to make sure we Loctite everything, you know, which is really difficult on the way you build these things back up. That might be the Gen 1 version of that. Don't know. Right, so everything's off on the underside now, if you know what I mean, so the chassis, so we can obviously flip it round and then start taking stuff at the top off. Again, just a fiddly thing to be working on. So we've got 4 at the back here, and then we've also got this blowback mechanism here, the simulation bit. So that one's already out. It's also got the 4 holes, which means it's the old version. It's now been revised by TM, because these would shear off and break with 4 of them. Mostly due because of the fact that they would come loose, then shear off and break. But they've revised it to 6 now, 6 screws, and which is just a bit more stronger, a bit stronger at the back. Hopefully none of these are sheared off. Again, another loose screw. Right, you shouldn't need to remove this part here. This bullet moving tray, so you can leave that intact, but in between the hole and there's a couple of 1.5mm ones, so I don't Loctite these ones deliberately. You want these to be loose, because obviously it can be a right easy one to round off if you put too much on them. Okay, so I'm pretty sure the one that seemed a bit short. Is that sheared off? Okay, so they're both the same length, just for reference. Okay, that then makes that this tray here, you know, come up, but it can't come up because this part's in the way. So what we'll do is we'll slacken them off. We can just move this charge handle backwards, and we've got access to another couple of 2s. 2.5. These will be different lengths. Okay, so long one this side. And short one at the top. Just going to put them separately over there, and then we've got those two there, so we know which is which. So that will just go past that now, and then obviously for the reverse of it you just have to lean and push it that way in order to get past. Usually these bolts have made themselves slack over time, but there's a bit of a trick to it. Okay, so we've got 1 and 2, both same lengths. Again, we're going to put them near these other screws so we know obviously that that's our sort of front bracket assembly there. So we can move the charge handle back, and then we should be able to just take the recoil weight off. You can then obviously check underneath to check the condition of the recoil weight. So obviously this is the Gen 1 assembly, so you've got the Gen 1 bracket at the back there. We can check the length of those screws and just see if anything's broken, but hopefully not. Sometimes this assembly right here can all snap, and obviously all the springs break and shear. There's not really much you can do about that. I mean, obviously if we supply the spares, it'll be, you know, not much, not many of them, so I'm not really sure that will help long term. Plus obviously it'll be the new version, so would you then have to change both the chassis and the bracket, because obviously we're not going to be providing the Gen 1 stuff anymore. Okay, so this rear bracket, we've got to remove obviously this okay, so there is still one clip, even though there's one missing from the other side. Got to figure out a way to get all this wiring through, otherwise it's going to be a bit of a pig. Hopefully there's some sort of a join between the two. I mean, God. You bear in mind you can fit a 2200 in the front of the rail area, you know, battery easily. 1-2 of them, especially on a brushless motor, is going to last you all day. You know, it's really difficult to get a Lipo bigger than 2600 unless you go RC World. So it's like, I don't even know why you need this rear wire. It's just, I don't know, sometimes you just got to say no. Hello, we've got some connectors here, I think. Some sort of heat shrink. What's going on with that? Is that coming off now? I've got those screws out. No. What are those screws for if not to take that off, eh? No, it's neat work, and you know, someone's took their time doing this. Not too bad. Now that we've got it all apart. Obviously the only downside to these bullet connectors, you know, with regards to customers, you know, so it's the same thing that can happen on scars. You know, is you put these wires on here, you got a little bit of tape holding these two together, and then what does the customer do this end? Obviously they just want a little bit of extra length on the wires, so they just, you know, and then obviously disconnected it. And you know it'll happen mid-game as well. And obviously the gun's coming back, well, you know, you only done this for me recently, and obviously the gun stopped working. Yeah, and it's more time obviously lost in the money sink that is gun teching. Right, so there's this rear bracket which you're going to have to slack off. The gearbox securing screw is missing. Looks like I might have machined some sort of a spacer. Right. I'm not sure about anything we can replace that with. Might want to find something, I guess, because obviously that's going to keep this gearbox in line with obviously that, and unless there's a reason why they've left that out. Oh, now we're going to have a headache with this stupid barrel, aren't we? you have to kind of get an angle on this fire selector, and then that will come out. Could be a pig taking this top cover off and putting it back on, so I just leave it on, as annoying as it is. Well, I'll just catch it on. There we go, charge handle anyway. So we want to disconnect these switches from the gearbox so we can pull that out. Obviously we can pull some of this wires through as well. So pull the motor wires through. And then pull through their stupid barrel. There we go. So obviously that's your chassis, and just put that to the side. There is some servicing that needs to be done on that before reassembly. If you're doing this from a second hand or servicing perspective, the charge handle, even though it's a bit more work and a little time consuming and fiddly, stripping apart that service, the handle, and then cleaning on the actual rail that it slides up in. We'll do that because obviously that can be a point of sticking basically with the dust and dirt that builds up if you're not on the outside of the gun over time. So people let go of the handle and it sort of stops halfway. We obviously want that smooth moving, so we'll try and do that afterwards. So you know, we can already see here just from an inspection, you know, quickly without even going inside, that obviously we've now got a physical gap between this gear here, you know, the shaft of it, and this bushing, so enough to get these inside of it. So obviously that's worn on this bushing to the point that it's now going north through it. So obviously not too many rounds later, we've got a nicked wire there. It's not too bad. Shit happens when you're gun teching. It's not too bad. Then we've got I mean, this is obviously an issue. You know, obviously this has got an upgraded you know, spring, and obviously ridiculous barrel. So you know, this is probably some sort of an attempt to obviously get more FPS out of the gun. Well, obviously we do an upgraded spring. You know, we do upgraded power spacers, and we do upgraded bushings. You know, so and they've been available since, well, about 2 days after this gun was released. So yeah, it just seems a bit weird to obviously go in, try and upgrade that, but not do this for the customer. But you know, live and learn in gun teching, so we don't know it all in a day, do we? Right, so we're going to disassemble obviously this, and obviously we've got to strip down these gears and redo these bushings, because obviously they will go. You know, it's just simply a matter of time on this gun. The amount of, it's not so much the problem with the gun per se. You know, these bushings have probably had a shitload of rounds, but you know, bushings are only rated really, you know, if you actually translate the TM manual, for about 50,000 rounds. That's when TM service interval is, and it's probably less or more on this one, you know. But the customer's going to be using thousands of rounds through the box mag. So let me just get that door. Righty, so there's a little screw there holding down these wires. Okay, so if we took that board up, done something with the, obviously the wires should just be going out this direction, so it looks like there's a bit of the conformal coating missing off there. Yeah, here we go. So this one and this one have been resoldered, and they've pulled it round and underneath rather than go in that direction. So, and obviously the reason the conformal coating is there is it's obviously very difficult to solder this board without affecting that. There seems to be something going wrong with this wiring up the top here as well. It looks like it's been resoldered for whatever reason. With this one going through the switch, so I don't think we need to remove any of that, so less we touch with that the better. It's a bit like a PC, you know, that's been there. Went into this bank one time to service their ATM machine, and they had a PC that was like 486 something or other. So and those ATMs are all running Windows XP and God knows how old. And I thought, you know what, I'll give it a quick clean, and I just took out the the base unit for the PC, and I just blew in there with a air duster. This crap come out. Years it's been sat there, and put the side back on, turned it back on again. Would it fucking boot? No. Should have just left it well enough alone. The old electronics, sometimes they're just fragile things, and they're just working, and then you just breathe on them, and then they're not. Right, so we've got two. This is like a sort of your front barrel support assembly. So we're got a pin going all the way through, and then we've got two screws either side. Again, you want to rock these bad boys just in case they've been Loctited. Obviously, there's another loose one. Get through. So when I'm knocking the pins through, I always knock through both directions just to see if there's knolling on one side. Yes, there was. So obviously if you'd have persisted going through the other direction without checking, then you'd have been smacking that knolling right the way through, and obviously it's just, there's only so many times you can do that. Right, there we go. Right, so gearbox out, and obviously this can be stripped and rebuilt, and then obviously I'm not sure what we're going to touch on this, whether we dare mess with this Frankenstein creation. I've only got about 5 more of these Mark 46 to do. Check what we've got going on. Fuck, that's tight. Do I even dare? Big fucking can of worms. We've got washers on the side here. What's going on there, eh? Just don't know why it's so tight to come off there. Has it been forced on or? Really inspect it. I mean, it's not like I've got the old bits to return it, is it? Look at that, how much tension that's under. I mean, it's AEP cut. Who knew there were mile-long AEP barrels in existence, eh? Yeah, I mean, it's good condition and clean, so if we needed to reuse this, we could just reuse that. You know, as we know with the MP5s, you know, there can be deforming issues with aftermarket hot rubbers, so could be introducing a, you know, can of worms with obviously the Psionic one. obviously we've not got the original barrel anymore because it's not been provided, so we're just going to use this. Make sure that's clean. Right, we'll give this one a go. If it's horse shit, then this is the last time we're trying the Psionic ones. We've just been bouncing so much between our hop and the Thor R's. I could swear we've got some decent builds under our belts with the Thor R, but the MP5 issues have been making me question everything. I mean, it's a little bit of a narrow window cut, but for this type of hop rubber, but we'll give it a go. Proof is in the pudding, innit? Looks like it's been modded. I mean, I've got a new one anyway, which is going to be going in there, which is slightly slimmer. And sometimes with the latest Marie, obviously, which is what this one is. Obviously, they've already designed it, you know, with the concept of putting quite a lot of lift, you know, for more modern ammos and stuff. Obviously these aftermarket hop rubbers are designed to put even more lift, you know, so for even heavier ammos. And what we found is that obviously it can be a little bit too much lift on like the R hops. So this is designed for the R hop, but we're not fitting the R hop, we're fitting the Thor R, which is like a sort of pre-made R hoppy type sort of thing, a bit like Maple Leaf MR hop, that kind of thing. So I'll fit this one, and either it puts too little on it or it puts too much on it. We'll find out, won't we? Seems to be a better fit there. Obviously it's a bit less difficult. Obviously we need, because we're going to be using a bigger nub with the copy of the Maple Leaf Omegas. Come on, you bugger. On the inside of that. Should make sure it's got that free movement up and down. It doesn't need any sort of sanding or anything. It's nice and loose going through there, so hopefully no bunching issues. Okay, so that's all ready to go back in there on reassembly, and then we'll test all that. So should be a hole in the back for releasing the anti-reversal latch. There it goes. We got a spring guide at the back here, so let's remove that. It's a perfectly good spacer. The only thing I can think of is it's a stock spring. You know, just we've got upgraded springs that we make ourselves. Just fit one of those. We'll probably stack our spacers in there just because I sort of know where we stand. The only thing is obviously we normally go 3 for a 3.2 build. This is going to be a 2.8 build ammo, and obviously it's got that long barrel, so you know, it doesn't look like a bad fit or anything like that. So it seems like obviously it's a good correct hop rubber. So yeah, it looks like it's going to be a standard increase that you'd get from obviously you know, having a longer barrel and you know, a presumably tight bore. So yeah, obviously it's going to give this build every chance for maximum FPS. Not that we need that. I mean, obviously at the moment it was 260 on 0.28, so quite down. So our spring should bring it up to 330 for you know, there's a normal spring plus a few spacers, and we should be there. I'll compare it to mine and we'll see. Maybe it's upgraded and the whole thing's just maybe the whole thing just, you know, all seals or something, and that's where the low FPS is. Just don't know, dear. What's time are we running out? So we'll just do screw comparison while we take them apart, just to make sure there's no different lengths. Let's go into the correct holes. Quite nice to see machine screws for once on a gearbox from TM. Fuck it. Okay, so last one's a bit short, which is obviously this top, just for reference. Thing to hold the top up together, like on the old PSG ones or AKs, P90s. Okay, so obviously other than the power spring going in there, it all just looks fairly stock. I don't imagine it's been changed at all. You know, so a common failure point is this bit of metal here. So it looks intact, but you know, I mean, that's the problem with failures, isn't it? So it's at the moment it's fine. So until it fails. So I'm going to sort of bring this compression set up. So obviously covering this, you know, hole, and then moving this in, you know, to do a standard compression check. That there is none. Yeah. So covering the hole up, obviously that shouldn't go down at all. So that's not good. So we're going to assume that this O-ring has shrunk. So we can do a cheeky O-ring trick on it. So we'll just slightly stretch this O-ring out. There's no guarantee on how long it will last, because when the previous gun tech done all this, he could have done this test and he could have got a full compression check. You know, then it's obviously been used and they could have lost it, or it could have never had it in the first place. No idea to tell, no way to tell. You know, we can just only do what we do, we just do what we see in front of us. So put that tablet plate spring to the side. There's a small hole in the side, so then we'll reinstall it later on. So we can check the runners and stuff and just make sure that there's you know, nothing that sort of need polishing on them, if you know what I mean. So some of the older boxes would have cast marks on them. You know, you get some quite good benefits from polishing, but these ones are pretty good. Okay, so that's the underside of the gear. And obviously they're specific shims which we do sell on the website. So I've got a 0.2 on the underside. Just going to jot that down. If I can find my pen. Take the gear underside. So top. Okay, so we've got 0.42 on the top. This is just for references, obviously we're going to be doing our own shimming. So the failure point can be these anti-reversal latches. So you see this corner that's on the end here. Obviously shouldn't have this nick out of it. It should be there all the way along. So obviously the gear effectively was only rubbing at that bit because that's where it was shimmed to. So obviously you've got all this area that could also be shimmed to, but it was only shimmed to that bit, and that's the part that it's been wearing. So you can see there that it's worn down that corner, and then obviously eventually it's going to reach the point when obviously that no longer latches and and does the anti-reverse anymore, and then obviously you get that sort of wind back noise. This piston really doesn't like going backwards, and that's obviously when you get the piston failures and breaking, obviously because one causes another, chicken and egg. So we do upgraded steel anti-reverse latches, which are this product here. So you can pop them in, and it strengthens that up. Again, it's hard to blame the gun per se, it's no doubt had quite a few rounds through it. Okay, 0.30. So with this aftermarket motor, yeah, I mean, this is definitely have had to have some sort of shim work on it. Those warheads are quite long. So 0.76. So it's just normal shims for the bevel, and this is a normal NGRS bevel. .30. Yeah, I mean the ones that are common to break are these, these spur gears, and that's mostly because something probably happens, you know. So obviously you can't just, it's like a car, you can't run into a lamppost without obviously the energy transferring somewhere. And obviously that's what happens when obviously you get a jam, or you know, something goes untoward, like bushings wearing, you know, causing obviously the gun to jam and get stuck, and you know, obviously what's going to shear the you know, teeth will, you know, because they just can't take it. going to get a flat blade screwdriver in there to make sure these bushing holes are clean. Flat blade is, where is it? Well, I had it earlier. What bloody hell is that, eh? Pretty sure it's just 6 and 5.9s. 6.1. 6.1. 5.9. 6.03, but they're the smallest ones. So obviously this, I just don't understand why we've got 6.1. Just, yeah, it's just weird. 5.9, yeah, I'd have taken that. But it's classic retro arms. Where's my friggin' reaming tool? Okay, so we're now in flush. Sorry. Again, we want to be press fit. So we don't want to be having to force it in there. We want it to just drop in there, and then we'll do the rest with bear and lock. So the other ones are not going in either, so I have to sort them out. Shame I've not got one of these for 6mm. It'd be awesome. I've got 7, 8 and 9. Still no. A bit bigger than 7. So they're in, but we'll Loctite those in a minute. Concept of doing this incrementally is obviously we're not trying to take out too much, you know. So that's sitting flush now, and obviously just pressed in, so it's good. Okay, so press fit for all of them now, nice and flush. A bit too tight, eh? Okay, so 638 Loctite, nothing else. Tell me this is fucking gone off. Because it's about £1 trillion a bottle. we're just going to put that one to the side because obviously we want that to dry. Right, so they're all seated. We've got the O-ring on there overnight. Got those things seated now overnight, and we're going to carry on shimming tomorrow. Righty, so we've got these bushings seated, so we're going to carry on with obviously shimming. Okay, so we've got these Eagle6 MK46 gears. You don't mind that this one's a different colour, so unfortunately there was a manufacturing problem and they done the colour process on these to obviously give it the black. This has still got the hardening done on it, it's just it hasn't got the that's nice aesthetic black that these ones have got. So you need to put a little of grease onto these to obviously protect it from any sort of rusting, and even if it does, it's if only sort of cosmetic. But yeah, obviously we love them being black, yeah, and we tried to get them to do it, but it would delay things too much getting them returned and redone. So we want to move forward with obviously these lovely new strong gears. Unfortunately the case that yeah, sometimes manufacturers just let you down, don't they? quite a bit of play on that. We'll take out a little bit of it. There we go. So I mean, we don't want to take out too much. Obviously, that we don't have any movement. We just want to take out some of that, you know, ability for this to, you know, during the shimming process, you to effectively shim something too low, and then obviously you're basically accidentally moving the motor downwards, and therefore, even though you think you're shimming it up correctly, you're actually pushing the motor, you know, at an angle like that, and then obviously the bevel's then obviously pushing against it, and that's when obviously things go wrong quickly. So we're taking out a bit of that slack just so we get a bit of movement, but also slack's gone. You'll find it is harder to shim, but you know, it's I just don't see how the motor being able to push down like that is ever a good thing. You know, it basically, in my experience, allows for this sort of, when you're running just the gears, for this sort of ability for the motors to sort of drift, and then you sort of get this sort of noise that's kind of like me as this thing sort of moves. You know, obviously we don't want this to be able to move. We want this to be fixed below the you know, the bevel, and to stay there in the correct position. Okay, so at its current motor height setting, I mean, it's a very safe setting, right? So as in, you know, it's been wound out, you know, so you know, obviously the motor's longer, so you know, it's been set quite far out. You can see obviously that it's hanging off the back of the bevel here. Sometimes with obviously the sharp tips on some of the pinions, you know, they can actually dig in a little bit to gears and stuff. So again, hanging this off the back is another way to sort of get into a nice sounding and safe shim. But you know, there is a substantial gap between obviously that and that. So at the top here, you know, suggesting that obviously, you know, we can wind it in a bit, you know, so you know, to more of a, you know, so that more of the, you know, because at the moment, like I say, only 3/4 of the actual pinion is touching the bevel, so we want to see if we can just increase that a smidge. You know, it's not saying specifically that the previous setting was wrong. There is an area of success on shimming, yeah. So to it working, obviously all we can sort of do is your own method, you know, and obviously to get to success. And obviously we're just trying to prove out here, if you know what I mean, why we think obviously that this, you know, is a little bit too far out, because obviously we ideally want, you know, that sitting in a bit further, you know, so that it's just a bit more of it is actually touching it. That will then ever so slightly just raise this up a little bit, and then obviously we'll set it then at the new correct height, much higher, yeah, with obviously this wound in a bit more. I mean, luckily on this particular gearbox, you know, look how much room we've got to set this shim height and to analyze and check on this. I mean, has there ever been an easier example to demonstrate this? You know, by comparison, PSG1, you know, where you cannot see anything. Yeah, that's PSG1. Okay, so you're trying to set motor height like this. Yeah, and this is Mark 46. You know, people like to say that NGRS is hard, but look at that. That's beautiful, just from a gun tech perspective. You know, it's maybe only ever slightly easier, if you know what I mean, maybe on SGR12, you know. It's just, yeah. Okay, so it's a bit closer in now, so we've obviously got much more of the pinion now, you know, in line with that bevel, which, you know, like I say, this is a fantastic example just from learning perspective, you know. I mean, look how easy it is to demonstrate that compared to some other guns. So wound in much more now, obviously, while we've still got the gap physically on top. Yeah, so we've still got space above. Again, if you're using very thick bushings, you know, sometimes that can remove a lot of that slack. And like I say, you definitely want some slack, which is obviously an issue we had with the bushings on that last MP5 we did. So now we've theoretically got motor height, you know, set within 90 to 95% of success, possibly even 100%, you know, you don't quite know. So now what we're going to do is we're going to set the bevel to the actual pinion. Get just a little brief file through there just to take out possibly any of that that lower one just seems a little bit binding, doesn't it? See, in order to get the shim done correctly, you know, gears have to freely move up and down. Problem is, due to the hardness of obviously these bushings, you know, you don't want them to be easily wearable, so it's going to be a very hard material to. So we're only really interested in sort of polishing it. bit tight still. Yeah, it looks like it does need quite a bit on top, even though we've wound that in. That's better. That's better. We want this movement up and down so that we can be sure that obviously we're getting the shim in the right position. It's just such a time-consuming process. Yeah, I'd say still 0.3 to take out. just another one. It's quite a lot on top, so which is not necessarily a bad thing. I'd rather have more, you know, room to remove with shims than I would have no room whatsoever every day of the week. Just gonna go to the toilet. Alright, let's give that one a go. There's not much left. Talking like a 0.1 under there. It's a lot on top. Would have been even more if it was left at the previous height. Go 0.2. Motor and bevel. All gears, and then gun. Smidge tight. A bit tight, doesn't it? Well, so one thing I was obviously hoping when we, you know, although we only got to have a brief test on this, is you know, it's really freed up this in terms of its spinning. So even though we actually shimmed it up and, you know, it felt a little stiff, actually spinning it and in air quotes bedding it in has really freed up this bushing and got it moving and stuff. So it just goes to show you that you could obviously set up and do a little test and feel like it's incorrect shimming, but once you actually go through the process of running a gun and getting that sort of bedding in period, you know, that concept of people saying that you have to sort of rag a brand new car to really sort of, you know, bed in the engine nice and early, you know, is you know, it's like it's a thing, you know. So to potentially, like I say, get it all freed up, you know, I mean, this is the thing about min-maxing. You know, maybe obviously, you know, us gun techs sometimes spend too much time thinking about that min-maxing, but I suppose it is the job. You know, obviously always trying to get better. You know, yeah, you could theoretically build up a gun, shim it up, get it all perfect. You know, pass it, you know, test it, run it for a month. And then actually go back in and potentially improve the shimming. You know, realistically, it's impossible to factor all that into, you know, paid work. You know, I know customers would all love it. You know, so oh yeah, I'll just drop it back off for its second rebuild. You know, to make it even better. Of course, everybody would love it, but just financially, it would just be completely and utterly impossible for any shop to do it. You know, and yeah, I think the expectation to try and do that would just be ridiculous. So, but you know, just goes to show that there's always more to be had, if you know what I mean. So there's never a bad thing, you know, even if a gun's working, you know, looking into, you know, rebuilding it or reshimming it. You know, there's always changes happening. Right, so I want to ever so slightly raise up this only by 0.1. So we need to somehow get 0.1 off the top and get it onto the bottom. Hmm, 0.1 there, nice and convenient. But we're just going to switch that out for a smaller one, just so that there's no interference on the width of the shim. Sometimes you can go back in and they've all just been ground down because they're right. Hopefully that's enough to just allow us to just get that motor in, because we're not able to back it out any further due to the length of the warhead motor. It's also obviously got this pinion, you know, pressed on even further already. You know, so it's already, you know the previous tech has already done everything you can possibly do. You know, and putting the pinion on as far on as possible. You know, you see the length of the shaft. If you were to put it at the far end, how long the overall length of this would be, you know, and it just causes a lot of problems. It's almost like, you know, you wish it was just ever so slightly, and I know they're developing new warheads because obviously they need to. You know, these are obviously great, and we are picking faults with the Ferrari. You know, it's still a brushless motor, but you know, it did have cause a lot of problems for techs. I've got boxes of these, you know, just, you know, like 20 of them, you know, just in some sort of state of disrepair because they're just so fragile, you know. You know, but, you know, like I say, once it's working and it's in, it's obviously a very performant piece of kit. There's no two ways about that. But, you know, would you buy the old ones if you had the new ones? No, of course you'd buy the new ones, you know, and I imagine and hope that they've listened to some feedback from techs and obviously shortened the overall length. That'd be nice to see, just to obviously make it shimming. Unfortunately, sometimes people make products but they don't actually fit products and test products. You know, and obviously you install 10 of these and you'll soon realise, if you know what I mean, that on average most guns you wish you could just back it out a little bit further, and or you're having to modify the base plate to actually have the motor physically sit further out, you know, which obviously you'd just be better if it was just physically shorter, which is tough because obviously, you know, the I've had to put a ECU on top of there, if you know what I mean, and obviously the overall length. I just think that right here, you know, they could have just shortened things, you know, so just made that tower slightly shorter, just made that shaft slightly shorter, just bring it in, much more compatible motor across the board, you know. So you know, I mean, obviously the perfection would probably be, because what they've probably done is taken the standard length of shaft and kept it all the same, but they haven't realised that obviously the overall length up here is increased. Thus, you know, because of this top section, you know, it's very difficult for it to, you know, to sit at the same height as a normal motor. So you put the cap on there and it's sitting a smidge or pushing it a bit deeper. Obviously we only need 0.1, 0.2, 0.3, if you know what I mean, to be different to other motors, you know. So obviously what I'd love to see is the overall length, if you know what I mean, exactly the same as a TM spec motor, you know. Right, so I've made the change on there, so we now need to do another test to see if we can get the shimming in, and obviously luckily this is, you know, so easy to shim on this. Which is a good thing, because I've got 4 more to do. So just be really careful when you're fitting the wires on the warhead motors, because obviously they've got very, very fragile connectors. just not getting enough adjustment. You know, we're trying to get this to come out and it won't come out anymore, so either we have to modify it so that obviously you know, it sits further out, or we have to keep on raising the actual bevel. It is just sitting in a bit too far for my liking. Which is interesting because we did see it sitting further out, so we've just got to make sure that obviously we've not got the wires complicating things by making it sit in, you know, further than it should be. Just a little bit confusing because obviously we've done the motor height test already, you know, that passed. We've obviously done the pinion, you know, the height test, you know, to check obviously, you know, and I know it's subjective, you know, but it felt like there was enough room on top of it for us to now obviously put the wires in, and you know, suddenly everything is just all incredibly tight. So that could suggest that we've got to shorten these motor connectors. Let's have a little look see. So we need to get this all out and check it outside of the grip because it seems like there's an incompatibility here, which suggests then that the incompatibility was on the previous build. So because they wouldn't have had any different with obviously the wiring, unless their wiring is different. We can compare them. Obviously we are using our own connectors, and they've slightly bent them over, though that sometimes just happens naturally on these weak connectors. Okay, so so when we put this cap on here, if you know what I mean, obviously it sits there, and then obviously we've got the screw basically. So this is kind of like Murray's motor spacer, you know, the little metal motor spacer that's in there, except obviously it's a big plastic one. So so basically this goes inside of the end cap here. Okay, and we've obviously tried to unwind this. Because we feel like the you know, the wires are, you know, we feel like obviously we had one setting when we set up the, you know, with no wires, and yet we put the wires in there and it seems almost like it's changed it, you know. So that suggests obviously that like I say, the wires are being pressed down by this end cap. So we need to now look into obviously why that's doing it. So obviously if I wind this out any more, basically nothing's going to happen because this cap physically will not go any higher into that. So obviously in this current position we're needing to obviously wind it out more. However, like I say, with no wires we saw a further out position. So like I say, modifying this to sit further out when, you know, it's pressing on wires to push it, that's pushing it in further, you know, seems a bit false. Yeah, so obviously, so we don't want to be, you know, modifying the wrong thing. If we're going to cut something, obviously we need to make sure it's the right thing. So so we'll demonstrate instead. If we know it's not that, we know it's probably then the wires. So I've got the original wiring out, that was obviously with the gun and how it's previously shimmed. So we've got this wire here, which is obviously a positive. So you can see the length of obviously that connector, and then you can see obviously the length of, you know, we're going to push that all the way on. We're going to take this cap. Okay, and you can sort of see the gap that's between the top of that. Now we're sitting up about it's quite hard to get in there, measure that, but so it's sitting about 2.58. But anyway, you can see a physical gap between the two. So obviously if we do this and then we do this, I mean, there's no gap there, you know. So we're talking basically 2.5 millimeters that, you know, this motor is being pressed down by the wires, not the physical top here. Yeah. So that would obviously be fit and flush, which is obviously how we installed it, and we got the motor height set. So yeah, so obviously, you know, having it pushed down by you know, the top of this is variable. You know, the size of those wires could be in a different, we need a fixed position for it to be, you know, pressing it down on. So we could obviously put, you know, a motor spacer inside there to obviously space that away, but then we've still got the issue that obviously, you know, the motor's sitting in too deep. So we really need, you know, to be able Righty. Right, so we could try taking a smidge of material outside of this, you know, just to, and hopefully that's enough. Obviously we don't want to take too much out, do we? So could always make a new one on the old 3D printer that's just a bit more sort of, you know, I mean, if it was going to be a regular thing. I can't remember too much because obviously Andy done most of the prep work on these. Obviously picked up from him. Righty, so let's modify this. Another option is obviously physically shortening this tab, and then we physically shorten, you know, the this connector here, so that it's just literally lower, you know. That's a fairly permanent mod then to this, you know, just taking the height off that. I mean, we may have to do it anyway, a combination of both possibly, because I don't want to take too much material off this. Just tidy the rest up with a file. I'm not sure it'd require a part making, because obviously the new would mostly fit in the new Solink motors, or possibly the new warheads if they're any good. And obviously the Solink is substantially more compatible across the board with much stronger tab connectors. do have a shortened wire set somewhere. That's probably where I've got that lying around. Probably why those prongs are slightly bowed over, because obviously it's pressing down in the middle here and pulling them that direction. But once they're like really shoehorned on, it's not too bad. Certainly better than where it was. This time I've taken the wires out just to see if we can set that height again. Yeah, it's so far out now. Fuck. You know, we're doing all this modifying, you know, and it's just bloody wires is the problem. You know, and nothing's changed obviously about this build. The parts are the parts that were provided from the gun that was tested working fine, you know. But, you know, I don't know how it was obviously, you know, wound in that far and not screeching, you know. So I mean, there is an area of success where obviously we could continually keep obviously raising the bushing, the you know, the gear up and up and up and up, and maybe there was a you know, a position found, if you know what I mean, where it didn't screech. But you know, it was obviously quite far in, wasn't it? Right, so that's a much better height that we've now wound it in at. I'm hoping that's now wound into a position that has clearance from the cables, which we'll test now. So for us to be in the same position that we just saw, obviously that needs to be there, basically. So once we add these, if it isn't obviously there, that's not great. It's almost there, isn't it? not bad. Let's try that. Oh, fucking mess. Fuck me. Well, I've got no fucking settings there that sound good. Now we've got our movement up and down now, which is good. But the settings off. So was it that change that we made before? But it seems just by raising it one, we shouldn't be getting that terrible noise. bloody spinning. Why is that just suddenly gone to not moving? Yeah.
For this refund, are we sending it goods and services or friends and family?
I mean, it's complicated, so obviously you got the protections on goods and services, Laura, so
Right, okay then.
but obviously we'll get charges, yeah?
We won't, they will.
Dunno.
And they've taken off the UPS shipping as well.
Yeah, because obviously we did attempt to ship it and it's not our fault they went, like their laws, if you know what I mean, so...
I'm going to send it friends and family.
Hardly any movement there. It's so weird how you get different results, you know, so it's just garbage in, garbage out. It just doesn't really seem like we've got much bounce at all, so I'm just going to remove that shim that's on top of it, see if we can get some. I mean, we've already gone through this process, so just goes to show you how fucking annoying shimming is. I think we need to go up a little bit. It just feels a bit tight. Yeah, it's got a smidge of bounce this time, so I think that's better. So we'll try that one. We'll just take out the slack now. Righty. Let's try that with grip. Well, that's a whole lot better, isn't it? A little bit forward, bad. A little bit backwards, bad. In the middle, fine. So we're about right there on that. But I would like to just blast it on a 11. About as smooth as it's going to get, I think. I'm going to get an amp reading, might as well. While we're here. 1.75 amp draw. I mean, there's probably about a 3 amp or at least 2 amp reduction over a standard motor. Those, you know, the brushless technology, could even say warhead, but we'll say the brushless technology is just so efficient, you know, in its, you know, battery usage. That's absolutely minuscule amounts of draw. Got to start off somewhere, so we'll reuse these other ones. See what kind of slack we got. On the nose, that one, but we'll probably run it for a bit and see if we can just bed that in. Just want to check it obviously against the piston. Um, right, so it's a much better seal with that O-ring trick, so that's good. So once the piston's in there, we can obviously check it against the actual sector gear to kind of see what kind of a gap is there. You can spin it round to see obviously how it impacts obviously the piston, and also obviously how it picks up the actual piston itself, which seems to be nice and clean there, and the fact that obviously the gear can spin round without obviously interfering with it, you know, is so that's a position. Obviously, you know, okay, it's a smidge on the tight side, so we might need to just run it for a bit, but I'm happy with the height of that. So we just need to do the shimming on the spur and make sure obviously it's sitting low enough, and then, you know, low enough that it's obviously it's not interfering with the central section of that, because obviously it's a V2 style bevel, and then low enough that obviously this top section here is obviously below the underside of the sector gear. And then that's then obviously the shimming set. We just then need to bed it in, do an amp test, and then obviously build the bugger back up. So Yeah, I'm not sure that one's loosening up. Yeah, it's nice and low enough. So so we'll take any height off the excess shims off the top side. Okay, so we need two 0.1s or a 0.2. That is AA12 shims, wherever they're hiding. Jeepers. Yeah, that one will do. It's 20. Straight on top. And then we'll put the excess in the pot so we don't get confused. Shit. If I'm going to run this in and bed this in, I want to get just a little bit of grease on the inside of that. Too much. Okay, just carrying on from last night. I think we were reassembling this to do the test, weren't we? Fighting crime, fighting crime. So just remember that if you're going to do long bedding in tests, that brushed motors can suffer from internal overheat. If they don't have metal bushings, they can often physically melt the plastic bushings. So just bear that in mind, that if they produce too much heat, that it's possible that they do that. Obviously with a brushless motor, there is no brushes to wear, there is no obviously, typically speaking, obviously any bushings that are in there you know, or bearings are going to be bearings, you know, so so yeah, you're pretty safe on just sitting there just rinsing away a brushless motor. That's the whole point of sort of moving to that technology, which means obviously we can bed those gears in a little bit, you know, get them free moving. Make sure that obviously the reading that we take isn't skewed in any way. So the live draw with those gears in, all three of them, is 1.5 amps, you know, live. I mean, the peak will be a bit higher because obviously that initial startup, but yeah, and obviously that's the one we technically write down the peak, you know, so that we can sort of consistently get a reading off it. But you know, that 1.5 live is, I mean, there's nothing untoward about that, is there? That's incredibly great result, if you know what I mean. So, and very low amp usage, which is good. Okay, I'm just going to jot this down before I move on. I feel so much better when the build starts going in the right direction as opposed to the wrong direction. It's just, it is a good feeling, you know what I mean? So, you know, when it does start to go right and obviously everything all gets together again and obviously the build's completed and, you know, yeah, it feels great, you know, to obviously succeed and get that result. We just had a lot of bad ones recently, you know, difficult guns, and it all compounds, unfortunately, and we just need a period of time of, you know, away from gun teching for a bit. So we're leading up towards obviously closing, and then we will consider reopening after a period of away time, but we need a little rest to get a little less jaded about it. Right, so we're obviously happy with the result. So what we'll do is we're going to build up this gearbox, and I've got a small secondary project to do. Once we've built this gearbox back up and got it set to the side, before we do the final rebuild on this, I do have a separate gearbox which was dropped off by a customer. The exact same gearbox, this one here, but he's provided just the gearbox. Problem with obviously providing just the gearbox is that obviously, you know, how do you do all this shimming? Yeah, so and even then it's technically not perfect unless you actually have a low receiver attached. You know, we need obviously to shim the motor height correct and do all that. And obviously if somebody just drops off a gearbox and just says, yeah, shim that please, shim it to what? Yeah, so shim it to what motor? What motor's going in there? So you know, the motors are all different heights. You know, so which one are we gonna bring it to? So so yeah, it's just gun teching. Gun teching's just evolved over the last 10 years, and you just can't get away with just sort of you know, what we used to do, or everyone, all gun techs used to do, you know, 10 years ago, 15 years ago. It's just and part of the complexity and the difficulty of that is obviously why we're stopping, you know. So I think we're gotten to a pretty good place of a gun teching, you know. I think we're more advanced than 95% of places that are out there, but you know, it's the bad ones, you know. Sometimes when you get bad ones, it just trashes your confidence, and you know, that's I think where we're at the moment, obviously with a huge workload. And yeah, I think once we get through that, we're going to have a bit of period of time off, but that's why we're reshimming that that gearbox, and we'll be doing that probably off camera between now and you know, building this back up into its gun, you know, to then obviously get its range testing, because we've still got to range test all that hot rubber setup, you know, to make sure that that's all working, and we don't have any more problems with these Psionic, you know, AEP rubbers. So we'll see. Obviously, if we get a good result, brilliant. If not, then obviously we're going to have to roll back to the TM hot rubber, because we just don't have huge selections of AEP hot rubbers to choose from. So it's just not many out there. So yeah, or in stock with us. So yeah, but yeah, well, I'm going to rebuild this back up. So if you're happy with the shimming and you know, everything's all set and whatnot, we do recommend taking like a measurements of those shims, and then that way obviously if during the reassembly you accidentally carve and the whole gearbox goes everywhere or something, then you do have a record of the shims. Okay, so 0.75, and that is the bevel top. So 0.2, no, another one. .3, which is the same as the shimming that was on the gun originally, which is really interesting, because obviously we have made a modification in that you know, the wires were clearly being pressed down, so it's interesting that we end up at the exact same place in terms of shimming, a successful shim result, right? Because the other one was sounding good and this one was sounding good, except now the motor position is not being pressed down by the wiring. Yeah, it's an odd one, isn't it? So it's well, that's why you write all this stuff down, to try and you know, science this shit. You know, obviously the bushings are now different. You know, the gears are now different, and yet, you know, the wiring is now obviously sitting at a different height, so that you know, so it's not pressing it down, and yet the result of the shim is exactly the same. So I mean, how can you possibly guarantee that those gears are the exact same size, or the bushings, etc., etc., you know? Right, compression's still good on the cylinder set. Nozzle. Gears, and all set. So yeah, got the new spring. So the other one was the original TM spring, so it's the original TM spring plus a spacer. So obviously we're going to switch out and we're going to put in so obviously it's a 2.8 build, so we're going to get 2 spacers rather than the 3. It's a little bit shorter than that spacer, so that spacer could be better if we want a smidge more, but less than obviously the but less than, you know, what 3 are doing. want to shim the spur up too low, in that obviously such a small amount is obviously engaging it, but also, you know, you'd have to be low enough that it doesn't impact on the sector gear. So when you're putting the anti-reverse latches in, just push the spring, just make sure that obviously it's not trapped and is seated underneath. Righty, don't want to forget that. So obviously we've got all the compression set in, the piston, the gears, anti-reversal latch, and then we can close this. What we're doing, we're checking for clearance of obviously the gears, anti-reversal latch, everything. just make sure that anti-reversal latch spring is correct. Excellent. So we're not really putting much, and I like to have it on the surfaces, not the threads. It's always worth checking the movement of things. Make sure obviously everything's all still moving. Okay, so tapper plate spring is in. Okay, so motor parts, motor screws, grip screws, assembly parts, which we just have another job to do before we can just finish that off. Righty, we're going to carry on with reassembling this Mark 46. Right, so we're popping the hop unit in first, and then obviously the gearbox is going to come in the back. We're locating pin for this gearbox. too much. Just try to get it onto the surfaces of the actual metal, as opposed to crazy amounts on the threads. It just takes more heat to get them to break up. Okay, so all the offsets back in. Obviously we're not touching that because obviously it's had work done previously, so we're really not keen on even remotely touching that. Don't really feel like that needs even taken apart, to be honest, which is a good thing. how you lay those wires is really important. Just get them nice and flush. And this lower one doesn't need removing. Just got to be careful when you adjust that. It takes some of the wires can slip through. Just put that wire back through. It's a pain, but especially since the wire has been played about with, you've got to make sure this is all nice and flush so that it goes on the inside of that chassis. So before we finalise it, we need to make sure the fire selector is moving appropriately, which it is not in the right position for that. Right, so you want underneath, once you're in the final position, you want the locating screws in for the underside here, which are these M3s, these M3 countersunks. I'm going to pop it a little bit locked onto the top of the screw hole. Okay, once you get that loose, located in its hole, it's going to govern the position, and then obviously we've then got these other two here governing positions. We want to make sure this is properly located, especially as we're putting all the grip and stuff on. So we want to pop this in here, so again we're going to locate it with the tube. So holes are different sizes, so in theory it's impossible to get it wrong. Just to prevent marking, I'll pop a little bit of grease down. Just between it and the surface. We hope to God that we don't have to do this again. Oh, and perfect timing for the phone. Okay, so I've just popped the screw in there because obviously it was missing. Just to basically straighten obviously the gearbox with the back of the support there. We're going to fix the support in. So be incredibly careful with the warhead wiring, you know, connectors. Fucking screws for that. No, you're fucking staying off. fucking rear wiring. Fucking idiots. Yeah, this is going to cause a fucking annoying problem. Probably going to have to fucking roll back now because it's stupid fucking wiring. Where the bracket wants to sit down, that's exactly where these wires go through, unless you go through the bottom of the bracket, but I'm not even sure you can route round that way. I think it's all going to have to come out. It's fucking shit, innit? All wasted time. It's two fucking lovely little things going forward here and fucking wiring at the front. What is the fucking point in all of this extra work, yeah? For fucking rear wiring. What? It's just the most stupid fucking waste of time that anybody's fucking come up with in terms of an idea. Fucking stupid idea. Oh, but I can fit the exact same size batteries in the rear stock that I can in the fucking front. What a fucking amazing achievement. That's the fucking problem with Loctite right there. Fuck's sake. So frustrating finding tools. Should have just put all this aside for fucking range testing and then carried all this on another day, because we might fucking have to do this all again if it's fucking hot. So why is that wire cover missing the screws? This is the problem, look. So the rear wiring, yes, you can put that there. Yes, there's technically a small fucking hole in the back of this space, or where the fuck I've put that. You know, but this is all meant to go in there, so that obviously when you slide it down, it doesn't catch on the side of the receiver. So technically speaking, you know, it's got no room for it. You know, we're going to have to run it past obviously the bushings or above this, which means obviously it'll be a little bit high, and then obviously, you know, would it then hit on the recoil weight? But we've got no choice but to obviously do it. And obviously, you know, in order to secure this cover, we need the fucking screws. It's ridiculous. Did not have any? Stand out, they're pretty obvious. Oh, there they are, look at those little ones. Fucking things on the end of a screwdriver. Now where's my fucking small screwdriver? Come on. Just work out this routing. So this recoil block so that's sat there. The recoil block seems to come in about like that. And obviously what I don't want to do is obviously bring the wiring down the top here and sort of catch on any of that. What we ideally want is it really realistically coming through that hole at the bottom there. Which is probably what it's literally been designed for. So what we're going to do is put this wire in the bottom hole. We're going to pretend that's going to be coming down there through this one. And we've got to figure something out up here to so it doesn't catch and get nicked. So it needs to be basically as flush as that. Or maybe something like that. And then what we'll end up doing is putting this through there. Oh shit, that's your fucking hole at the back in it for the disconnecting, you know, for the popping the anti-reversal latch. Let's bring a fucking hole out underneath it. That's big enough. Because however it was routed before, if you know what I mean, I can't see that it was just, well, it's just fucking pure luck, if you know what I mean, if they weren't catching on that bracket. Right, drill bit. Okay, so we've got a hole now underneath. It should be big enough for obviously these wires to go through. And they can come out there. And that's a little bit neater, isn't it? Fuck me. screw in there. Right, like I say, we've got a range test still to do on this thing, so we are just going to get this back together, mostly because obviously it's I need the desk for something else while we wait for the appropriate time for range testing, and obviously putting the bits back on the gun is the easiest way not to lose them. The downside to obviously not having the immediate ability to just walk outside and test at 100 meters. I'd almost describe it as a requirement if you were trying to set up somewhere to, you know, a business to do gun teching. It is a significant blocker, shall we say. Having no light outside to test, or you're not having an appropriate place to test. You want to carry that momentum on a gun going all the way through from start to finish, but you can't, because obviously you can't just walk outside and shoot 100 meters. So Okay, so there's a much better routing of the wires now, obviously underneath the block there, as opposed to trying to bring it up and over. It would have come up through this gap, obviously behind this thing, and it's just, yeah, that was just too complicated, or too worth a risk. So obviously we want to bring the wire underneath, which obviously we have done, and obviously that's much neater. So fingers crossed. Anyway, obviously we haven't finished the build. So when you put the recoil weight back on, put this plate between the bracket and this, and then get all your screws in that you can see. Let's just do this motor. Quite difficult to do these up massively tight, these connectors. Obviously we do have this situation of this being incredibly pushing down on the wiring, as in the, right on the limit, so we've only just made enough room for it. So I don't believe we'll get like a loose connector coming off, because I think it's physically being pressed down onto the motor, so should be alright there. For when the gun's shaking and upside down, because obviously the motor would be upside down and the card player's using it. There he is, hiding in that lot. Okay, so we've got a long side, which I believe is this top one. Don't know how much to do obviously on these friggin' Loctites. So obviously we don't know yet if we're going to be going back in. Just do a small dab. Really don't want to be going OTT on these. We obviously don't want them backing out. This is the dilemma, but obviously you've got to service the damn thing, am I doing wrong there? Oh, it's the wrong fucking hole, that's why. Fuck's sake. Isn't it amazing how you can do 50 of these and just forget where a screw goes? It's just unrealistic to expect, you know, somebody to only ever work on one gun, although I suppose there are some specialists out there only ever just work on the one thing. So once they're tightened on, you should be able to kick this back up and then get the other ones in. Damn it. Got to slacken that off to get them in there. Should allow you to get that tray past. While obviously, you know, if you're wondering obviously how to, you know, get those in, I believe the official process would obviously be to fully disassemble all this, you know, so that obviously it's not in the way and this tray is out of the way, but this is a pain with these springs, so it's just not even worth trying. Okay, so these little ones you definitely don't lock tight. It's 1.5 Allen keys, you never do the 1.5s. As much as it annoys people with magazine release catches, but it's just not worth it. Let's see the trembling one off. quite common to come in loose and causing problems. So again, don't go too mental, but a bit of Loctite on that. Fuck me. So angry lately at the gun taking. I've got no patience for it anymore. I've got all my e-commerce orders to do today still. You know, somehow I've got to squeeze out time for this. Fuck. More thumbs. What's going on with this front? Okay, now caught that foot. Pretty sure it's that small one. Might be too long, but we'll try it. Obviously it's not countersunk for the always the case, isn't it? Don't come out, it comes at 100 mile an hour. Still not worked out how these friggin' barrels come apart. Looks like there's a seam in there and it looks like this part comes out. Seeing the barrels just press fit, that could also be a thing. Jesus. It's fucking been rounded off. It shouldn't even be in there. Problem with the rounded off stuff is once you pop it in there and you can't get the buggers out, you know. So it's just not worth risking a rounded anything. It's a shame it has a perfect length, that was. Wide button head before, but this will do, I think. we go. Now don't lose them again. Fucking palaver, eh? Taking the bipod off because it's just a fuck ton extra weight for me. What we're going to do is we're going to take these parts and this, I'm going to bag them. This we're just going to shove onto there, and I'm going to get my range testing done like that, because I'm not sitting there fanning around getting all that back together again. Just have to strip all this bastard back down because it's fucking 50 FPS hot or some shit. So more of the bullshit that we've got to deal with as gun techs, that the FPS could be too small, too big, you know, you take your best guess with the springs, but we'll see what it comes out at. Alrighty, so fingers crossed, obviously I'll do the final assembly on this after range testing and the FPS is all spot on, and there's no more. If there is more, then we'll carry on the video. If not, obviously I'll switch over to range testing.
Okay, with the, in theory, past range testing, we want to do a stress test now, so we're just going to do the final build for that. Although we did have another Mark 46 fail, so yeah, hopefully that's not going to be the case with this one, but I guess we'll see. Oh, there was some requirements, weren't there, for this wiring at the back here. I think we were binning that off. So I made all that effort to try and preserve the tool hole at the back here, so that obviously, you know, the customer can still put the tool through. And then obviously where the tool is, that's where the other companies obviously routed the wiring through. I suppose technically there's no other way unless you you know, drill it out, which obviously seems pointless. And you can still obviously, you know, get to the thing now that I've obviously, you know, freed up that hole. But yeah, previously you couldn't. So we just pop this extra bit of heat shrink over, like so, where the actual join is, and that'll just give it a little bit of extra rigidity to, in case someone tries to yank it. Let's go on the bottom. That's frustrating. Take this to one side. That's annoying, there's shitloads of hole at the room at the top but not the bottom. Just going to have to go in through the bottom. And then we do that. ask you this again. Do you think I need to do any of this with a front wire? Nope. Just saying. A ringtone, I think we have copyright one day. You know. Okay, I'm going to give this a blast and we'll see how it goes. Hello, Richard speaking from Eagle6. So this is a stress test of Mark 46, the second-hand one that was dropped off. So this already had some upgrades. It's already got a warhead motor in there, and it's got a ridiculous long barrel thing that goes all the way through. So someone's managed to get the original barrel out of the removable barrel and then remove that and then they put things. So you just got to be really careful when you obviously try and take this barrel out. You know, because yeah, because it's got this, like I say, long barrel that goes all the way through. So I mean, you can do it, but you know, just be careful. You don't want to break the hop unit or anything. I'm assuming because of that they've then rewired it because obviously it is a bit of a pain in the butt. You know, it seems to be a little lower, you know, on FPS than sort of an average ones. I'm not even sure it's even gained FPS, you know, by putting a solid barrel all the way through as opposed to the two-piece. I got on really well with the, you know, the two-piece system. You know, I felt like it was already a really accurate gun. I just think it's adding complexity, you know, so without any gains. But, you know, that's how it is, and we kept it in there, and, you know, it's, like I said, we've done a range test, and we thought it was fine, so we left it in there. So yeah, so obviously we've installed a Psionic AEP hot rubber, which we've been having issues with, but this one seems to be holding up, so so we're going to leave that in there and see what obviously extended testing with the customer is like. We've got upgraded Eagle6 spring in there. I think it was the original spring that was in there with the power spacers, so we've put our spring in there. That's gained some FPS, and then we've put some power spacers in there, enough so that we're not over on the 2.8s. So it's 278, I think, now on 2.8s, with obviously 296 being the limit. So we've got the Psionic tensioner in there. We've got the Eagle6 sort of reduced height hop knob tensioner in there. We've got the retro arms bushings to replace obviously the plastic ones that are in there. We've got the Eagle6 steel anti-reversal latch to replace obviously the original TM one. And we've put the Eagle6 steel gears inside there. And yeah, we just want to obviously test it. What we noticed a failure on a previous gun that we tested with this hot rubber is that we saw extremely erratic shooting. So obviously, as long as everything all stays pinpoint down there, I feel confident in the build's holding together. And at that point, obviously, all we can do is hand it to the customer for, you know, long-term testing. And obviously, if there's any problems, we'll just do it under warranty, which obviously is inconvenient, but you know, sometimes things happen. But the main thing is obviously getting through an extended shooting test with this magazine here. So, which will empty a bunch of rounds and see what happens. Getting the odd outlier, if you know what I mean, but not as bad as what the other gun is. I think what we'll do is we'll pass this one because the customer is coming tomorrow, and I'll say it doesn't seem to be like crazy spread and stuff, but if it is bad accuracy, if you know what I mean, then you know we're happy to replace that hot rubber under warranty. You know, yeah, it's stuck between a rock and a hard place. There's not many AEP hot rubber, you know, hot rubbers out there. You know, this company was advertising a working product, and you know, I've had 3 failures now on 3 different guns, and that's just, you know, the tip of the iceberg. There's others as well. You know, at this particular point, obviously, we're not installing it in any other guns. You know, it's hopefully a good result on this one. You know, but yeah, it's if it's not, then you know, obviously, you know, incredibly widespread. You know, terrible accuracy. I just don't have time to retest it and you know, before you come, unfortunately, at range, because the issue is obviously extended amounts of use, yeah, which then causes it, yeah. So you know, long periods of shooting, which obviously a support gun's going to do, isn't it? You know, I think the material they've used is way too soft. and I think it obviously results in you know, as it heats up, if you're not being some sort of weirdness happening inside there. So yeah, like I say, that one's going on there. Like, give it a go. Any problems, you know, let me know, and hopefully it's all good. But I'll give you a message and see if you still want to collect tomorrow. If not, I'll run it through some more testing on the weekend. So.